Chemical equilibrium is a fundamental concept in chemistry, particularly relevant to food safety. It refers to the state when the concentration of reactants and products remains constant over time, indicating a dynamic balance. In the context of food preservation, understanding equilibrium helps in determining the shelf life of perishable items and the effectiveness of preservatives, which inhibit microbial growth. Chemical kinetics, on the other hand, deals with the rate of chemical reactions. It is crucial for food safety officers to comprehend how quickly reactions occur, especially in food spoilage. By knowing the kinetics, professionals can formulate strategies to minimize risks in food processing and storage. Together, these concepts offer insights that are pivotal in maintaining food quality. Here are 10 key points to understand about chemical equilibrium. 1. Dynamic equilibrium occurs when the rate of the forward reaction equals the rate of the reverse reaction. 2. Changes in concentration, temperature, or pressure can affect equilibrium. 3. The equilibrium constant, K, quantifies the relationship between products and reactants at equilibrium. 4. Le Chatelier's principle predicts how equilibrium shifts in response to external changes. 5. Equilibrium does not imply that reactants and products are present in equal amounts. 6. Catalysts don't affect the position of equilibrium, though they speed up the attainment of equilibrium. 7. Equilibrium is state-dependent. Reactions can shift based on conditions. 8. It is vital for food safety practices during storage and processing. 9. Reversible reactions are those that can reach equilibrium. 10. Equilibrium must be monitored for quality assurance in food products. In chemical kinetics, the following key points stand out. 1. The rate of a reaction can be influenced by concentration, temperature, and catalyst presence. 2. Activation energy is the minimum energy required for a reaction to occur. 3. Reaction orders indicate how concentration impacts the reaction rate. 4. Rate laws describe the relationship between the rate of reaction and concentrations of reactants. 5. Reaction mechanisms break down the steps involved in a chemical reaction. 6. The half-life concept applies to first-order reactions in a constant manner. 7. Temperature affects reaction rates significantly, following the Arrhenius equation. 8. Enzymatic kinetics are vital for understanding biochemical processes in food safety. 9. Reactions can reach a point of completion or equilibrium. 10. Understanding kinetics helps mitigate food spoilage risks. To solidify this knowledge, here are 10 frequently asked questions in the form of multiple-choice questions, MCQs. 1. What does chemical equilibrium indicate? A. Complete reaction. B. Dynamic balance. C. Slow reaction. D. Irreversible process. Answer B. 2. What principle guides the response of equilibrium to changes? A. Dalton's law. B. Le Chatelier's principle. C. Boyle's law. D. Avogadro's law. Answer B. 3. The rate of a reaction is affected by which of the following? A. Temperature. B. Catalysts. C. Concentration. D. All of the above. Answer D. 4. What quantifies the relationship between products and reactants at equilibrium? A. Increase activation energy. B. Lower activation energy. C. Change equilibrium position. D. All of the above. Answer B. 6. Which equation determines the rate of reaction with temperature? A. Arrhenius equation. B. Dalton's equation. C. Henderson equation. D. None of the above. Answer A. 7. What happens to a system at equilibrium when temperature increases? A. No change. B. Shift toward products. C. Shift toward reactants. D. Reaction stops. Answer B. 8. The time taken for half of a reactant to be consumed is known as A. Reaction time. B. Half-life. C. Completion time. D. Activation energy. Answer B. 9. What is required for any reaction to occur? A. Low concentration. B. High temperature. C. Activation energy. D. Catalyst. Answer C. 10.